Alright, so welcome to the lunchtime video. Unfortunately, we didn't have an after work video yesterday. I just kind of wasn't feeling it, and then later in the evening I had like a monster stomach ache and I could barely even like get up, let alone do a video or anything like that. But the good news is I actually feel like a lot better today, and this stomach ache like led to like a 5-pound loss. Like I ended up like overnight losing like 5 pounds, so that's not necessarily a bad thing since I'm kind of struggling with weight right now. So yeah, I feel great. I'm much leaner than I was yesterday, so yeah, I'm feeling, actually my stomach feels better than it's felt in a long time. Absolutely no pain. So let's continue on with this. Hopefully I do have a some fast food coming at 5 today, so hopefully that doesn't destroy my stomach. Yesterday I had really healthy foods, so like it might be there's too much like fiber. I'm not used to that much fiber, something like that, but I feel great now, so let's keep going. Hopefully that will extend into the evening tonight, and I can do an after work video. So what I wanted to do in the after work video is just finish reading this RFC. We got nearly through the end, but we stopped because but we stopped, so we didn't get all the way through this section here, the section where it outlines steps. Yeah, so it says like the first step and then the next step. We didn't get through all the steps, so I guess what I'd like to do is just read the rest of the steps, maybe kind of poke around on the command line a little bit more, just kind of get into the weeds with something, and however far I get or anything like that, just come up from it, mark it off. And then this evening, we'll be moving on to QoS, the last topic before the test. Really good news, because we're now measuring time until the test in days. It's probably more reasonable to measure it in weeks still, because it's about 3 weeks away. But it's definitely 7, 21, 22, 23, 24, 25, 26. Yeah, less than a month, 26 days. I think it is reasonable to measure it in days. Okay, so we're going to finish reading this RFC. In summary then, the following steps are required. And these are steps that are required for okay, I don't know what these steps are required for. Oh, they're required. Wait. So create the set of group to Anycast RP address mappings. The first step is to create this set of group to Anycast RP mappings. Group to Anycast RP address mappings to be used in the domain. Each RP participating in an Anycast RP set must be configured with a consistent set of group to RP address mappings. This mapping will be used by the non-RP routers in the domain. Configure each RP for the group range with the Anycast RP address. The next step is to configure each RP for the group range with the Anycast RP address. If a dynamic mechanism such as auto RP or the PIM protocol independent multicast version 2 bootstrap mechanism is being used to advertise group to RP rendezvous point mappings, the Anycast Internet Protocol IP address should be used for the RP address. Unlike the group to RP mapping advertisements, MSDP peerings must use an IP address that is unique to the endpoints. That is, the MSDP peering endpoints must use a unicast rather than Anycast address. A general guideline is to follow the addressing of the BGP peerings. For example, loopbacks for iBGP peering, physical interface addresses for eBGP peering. Note that the Anycast address must not be used as the RP address in SA messages, as this would cause the peer RPF check to fail. Finally, each non-RP router must learn the set of group to RP mappings. This could be done via static configuration, auto RP, or by PIM v2 bootstrap mechanism. This is typically accomplished by causing each RP to inject the /32 into the domain's IGP. Each MSDP peer receives and forwards the message away from the RP address in a peer RPF flooding fashion. The notion of peer RPF flooding is with respect to forwarding SA messages, MSDP. The BGP routing tables are examined to determine which peer is the next hop towards the originating RP of the SA message. Such a peer is called an RPF peer. See MSDP for details of the peer RPF check. State implications. It should be noted that using MSDP in this way forces the creation of SG state along the path from the receiver to the source. The state may not be present if a single RP was used and receivers were forced to stay on the shared tree. Since the solution described here makes heavy use of Anycast addressing, care must be taken to avoid spoofing. In particular, unicast routing and PIM RPs must be protected. Both internal and external unicast routing can be weakly protected with keyed MD5, as implemented in an internal protocol such as OSPF or in BGP. More generally, IPsec could be used to provide protocol integrity for the unicast routing system. While not a security issue, it is worth noting that if unicast routing is unstable, then the actual RP that source or receiver is using will be subject to the same instability. The mechanisms described in RFC 2362 should be used to provide protocol message integrity protection and group-wise message origin authentication. As is the case for BGP, MSDP peers can be protected using keyed MD5. Okay, so that's going to be it. We don't need to read the acknowledgments or the references. So this is now completed and read. So let's make a title for the next one, the one I'm creating right now. Okay, and we'll one thing I wanted to talk about quick as well is my plan for after I've finished all of these modules, which hopefully is going to be pretty soon. So it's going to be by next week. So I'm going to have about 2 weeks, 3 weeks to just kind of freeform and study the way I think I need to study. And at least for one of those weeks, let's see here, or weekends rather, the weekend of the 13th and 14th, or the 6th and 7th, you know, probably first both of those weeks. The 6th and 7th is actually next week. What I'd like to do is go into my notes folder, and now I found just through Google some free demo versions of old V1.1 workbooks. So unfortunately they're not going to be for the version 961 of the exam. They're going to be for the version 960 of the exam, which was an 8-hour exam. This is a 6-hour exam. So we're going to have a little bit of extra content on there, but I don't think that's necessarily a bad thing, unless of course I don't have time to complete it. But what I would like to do is just take the curriculum out of this. So yeah, we can see we've got the table of contents here. So what I would like to do is just say, okay, here's my test. Part 1 of my test, initial system settings, and then just come up with whatever I can, practice it, make sure I'm comfortable with that. Part 2 of my test, set up SNMP. Part 3, make some firewall filters so that a jump host can only access, so that we've got 2 jump hosts and one can access and one can't. And then interface configuration, that's easy. Scripting, I'm not exactly sure what to do with that. I'm not sure if they're going to ask me to actually script something, or if they just expect me to know scripting in order to be able to do the tasks they give me in the time allotted. That seems more like what I would expect, is just scripting helps you pass the tests, and if you don't know it, you're not as likely to pass. But there could be specific scenarios where they ask you to script, so I'm not exactly sure what to do with that, but I will, I think, try to refresh myself on that some way, somehow. So yeah, I think I made it clear what I'd like to do. Now I do have multiple of these, so perhaps one is better than the other. Let's take a look at how they differ right now, just to get a better sense. So we'll duplicate this tab a few times. Okay, so we've got 4 resources, so let's get a 4th tab open. Okay, and let's see how the table of contents differs. Okay, so it looks like the table of contents is pretty much exactly the same, but what we'll do is we'll go and create our own custom table of contents, and you know what I might want to do is just focus on the lab challenge. I guess we'll just make our own lab challenge, and then we'll have these tasks, and then I think we'll make like subtasks that pull in all of these, and make sure that because this is the 8-hour exam, we can filter out anything. For example, well, I don't see anything offhand, but we'll make sure to cross-compare it with the current curriculum for the 961, and if there's anything that is not mentioned in the 961 curriculum but is mentioned in the 960 curriculum, we won't include that in our practice session. And even if it happens to show up, I think I would have a better probability of passing if I studied more deeply the concepts that were declared to be on the exam than the ones that were not. Okay, so we finished reading. So I think the next step. Oh yeah, see, this is nice. They give you the here we go. Look at this. They give for the full day lab challenge. It looks like we've got 3 full day lab challenges here. So I guess we can do a different full day lab challenge every day. Yeah, we got one that kind of looks like it matches from that other book. It looks like we've got another one that's yeah, a little bit more complicated. Centralized authentication management, setting up with TACX or Radius. Yeah, it's going to be pretty challenging, but I'll have the whole weekend to do it. Right now, I just need to focus on making sure I make it through what I wanted to do beforehand, before I do that, to give me plenty of time. And then, of course, I can still work on those full day lab challenges during the lunchtime videos. And the after work videos, the only problem with that is I won't be able to get the experience of just sitting down and working on it for 6 hours. as is going to be the case when I take the actual exam. But you know, my work day is 8 hours, so, and it's literally just during a work day on 8, so it shouldn't feel too challenging for me to do that. Might be, you know, at work, if I want to take a 5-minute break, I can do that, and it's not going to be as doable for me to do that sort of thing during the test, so it might be a little bit more challenging, but I'm really not that concerned about that aspect of it. Okay, so let's pull up the lab and try to see, like, because we did that video before and it just wasn't working, so see if I can troubleshoot that. Yeah, so we did the commands in that video that he wanted us to do, but they weren't working. And also, I'm not sure if I had MSDP neighbors. Oh, it's show MSDP session, I think. Peer. I knew it was another word for neighbor, which session is not another word for neighbor, but okay. So the peer is going to be 172.26.0.3, and it's established. Okay, perfect. So yeah, let's try to go back to that video that I watched. So it's going to be part of the prior topic, but I think that's going to be okay.
On rec 200, again say show IP ID brief. Then you can go ahead and...
Yeah, so there was a point where everything was aligning, and then all of a sudden it just wasn't aligning. So I think on rudder 1 things were fine. Let's check. So yeah, on rudder 1, if I do a show pim join extensive, everything looks okay. We've got a, oh no, even on router 1 there were problems. The upstream neighbor isn't filled out, it's unknown. So even here we've actually got some problems. So why isn't it learning the upstream neighbor? And what is the upstream neighbor even meant to be? Let's just see if I'm learning all of the loopbacks through OSPF. Ah. Oh, what the heck? Why isn't it? Oh, 16. God damn it. Okay, yep, so we've got 2 through 7. Looks good to me. Huh. Okay. Oh, man. Oh.
Set up this SVT file. That's all that it means. But this is
Yeah, so I'm not sure what to do about this. Let's go back and see. I wish I could search videos. I guess I could search the transcript. Yeah, so I can open the transcript. Yeah, and then I can search the transcript and Oh, can I switch to screenshot? It'd be nice if I could. Toggle timestamps, what does that mean? Oh, why wouldn't you want the timestamps? It makes no sense. Where's a search? I mean, maybe I can just do a regular and then do a show protocols. Okay, so yeah, now I can do a search and I can take a look at every place he did a command, and we can go ahead. So he did run show for all of his commands, so that makes the searching really easy, because we can see it looks like he did 18 commands, so we can check each of the 18 commands that he did, and if we don't know which he did on, we can skip to the timestamp. Oops, it doesn't look like we can do it automatically though. I wish we can. Why can't we skip to the timestamp? Oh, and I'm freezing. I don't know why my browser's freezing right now. That sucks. But it looks like this is going to be a good bet. Oh! Okay, I thought it was freezing because it was skipping to the timestamp, but I don't think that's the case. Oops, and I'm not. I want this to, be to register on my official channel so I get better. So the algorithm, because see, the algorithm is. I can't escape basketball for some reason, but on my other channel, I seem to. Oh, that's funny. On my other channel here, I actually get better algorithm results than the other one. That's kind of sad. And the funny thing about that too is here I'm not subscribed, here I haven't liked, but here I both liked and subscribed, but yet I'm not getting content that I want. I'm getting content shoved down my throat that I don't want. I kind of don't want this. Like, I'd rather have another video relating to this show up here than that. Art of Network Engineering podcast, that's actually pretty good. I stumbled upon that. They have a Discord server, so I do recommend people check that out. Join the Discord server. For nothing else, if you don't have anyone to say congratulations after you pass an exam, they're happy to do that for you. Okay, so let's try the same strategy of looking at the transcript and seeing every time he says run show. Okay, so it looks like I'm unable to open the transcript right now. Let's try refreshing and try to open the transcript again. Okay, so it looks like I can't open transcripts using this account. Oh, okay, here we go. So I can do it. It just shows up in the side instead of underneath as it did before. That's totally fine. Okay, one thing to understand about these transcripts though is it's auto-generated, so I might be missing some things, but 18 results is good enough to me. So here it says show pin interfaces, but it's clearly going to be show PIM interfaces. Okay, so let's just do the show PIM interfaces command on all of the routers. Make sure that they're all up, so I've got to open all of the routers. Come on, there we go. All right. Everything's up there, looks good to me. Okay, so, oh, I'm standing up for some reason. I might need a glass of water here. All of the, everything looks good here. We've got all the interfaces added. Let's move down to the next command. Show PIM neighbors. So I'm gonna do show PIM neighbors on everything, and then grab a glass of water. Okay, so we've got an option here, HPLGTA. So we've got the hello option hold time. We've got the hello option DR priority. We've got the hello option LAN prune delay, the generation identifier, tracking bit, and the hello option join attributes. But as far as I can tell, everything looks good. I mean, I guess I'm wondering if this interface needs to be added as well and why that's missing. But let's check the other one. I mean, on routers 5 and 6, if we can see that it's got 2 interfaces, but here it's only got 1, we know there's a problem. Everything looks good here. We've got neighbors. Oh, you know what? It's not going to have a neighbor because the other side isn't a part of it. It's just a host, I believe. See, that's the thing. I have no idea. I don't know what's meant to be a neighbor and what's not meant to be a neighbor. I mean, to me, it seems clear that all the routers are meant to be neighbors, but is a router meant to be a neighbor with a host? I would say no. For the same reason I know that OSPF does not require a neighborship between the host and the router. But this is all new to me. This is my time to really try to figure this out. Okay, so now here's something interesting. Show PIM RPs. Let's see.
I say run show PIM RPs.
Oh yeah, RPs, rendezvous points. Okay, so yep, that confused me, but that is what it is meant to be. Show RIM RPs for rendezvous. Yeah, RPs for rendezvous points. Okay, so let's see here. Okay, so everything seems okay. Let's try this on all the commands. On test day, now this is where things get a little bit tricky because I'm going to be taking this exam at home now instead of at the test center. So the test center has licenses to secure CRT. Here I don't have any such license, so I'm kind of at the mercy of whatever was compatible with GNS3, whatever came with it automatically. So I might want to look into switching because this is definitely for the birds, going into each one and entering it individually. We can see he is using a much better terminal program than I am, where he has the option to send commands to all sessions. I don't believe I even have that option at all. Nope. So that's something I'm going to need to look into. It looks like all of the RPIMs are fine. I guess I'm curious to see what his RPs look like, if they match the loopback or if they're all the same. Okay, so here's the interfaces. We did that command already, so that's because I went. Oh, I see, because, okay. Yeah, so as I move to the, okay, show, okay, let's try the next command. I would like to see, well, actually, let's do this. Let's search for RPs. And I want to just see what RP addresses he's using.
I say run show PIM RPs. there's not.
Okay, so I don't think he set them up yet. It's going to be in a different section of the video.
Show IP pin RPs extensively.
Okay, so on router 3 we've got an RP of 0.3. I'd like to see what his RP looks like on a different router.
That would actually show you all of the register states that are on this RP. So remember that command for troubleshooting purposes. It's a little bit different than the run-of-the-mill command, which is usually show IP pin join. But in this case, it happens to be show pin RP's extensive command that would show you this. So this is the group, and this is the source. Who is the first hop router? So which router is sending you that register message? So in this case, looks like the default on Junos is to use the loopback address to send the register message. This is a...
Okay, so we've got... yeah, so we've only got 3 results where he says this command. So unfortunately... Oh, you know what? I think this is evidence enough that they are meant to be all matching their loopback, and they're meant to all be unique, because we can see it requires a hop addresses. So, and I think they're following the same syntax as the RP address here. So I think that's good enough evidence. Okay, so yeah, and I think everything looks good as well. Let's go back through our run show output and keep following along. So one thing I think I'm going to do is just free myself of this window here by just writing down all of the commands. Okay, so we've got 18 commands. Might have some duplicates, but the first one is going to be show PIM interfaces. Next one is going to be show PIM neighbors. Then we've got show PIM RPs. Then we've got show IGMP group. We've got we've got the same one, so here's a duplicate command. Yep, and then show PIM join. Yep, show PIM join again. Yep, show PIM RPs, we've already got that one. Show PIM RPs, that's a common one. Show PIM join looks good. Show PIM join, perfect. Show PIM join extensive. That's just a knob, it's basically just show PIM join. Show PIM RPs. Show PIM RPs, show PIM join, show PIM join, show PIM RPs extensive, show PIM RPs extensive. So we've got 6 commands here that are essential and used multiple times in this video. So you know what, let's just do all 6 on all of the routers. Another thing we can look for in the transcript is the word set to see what he wanted configured in there. Oh, you know what? Let's throw a pipe no more. Okay, make that easier. Oops, and it looks like it actually wrote it, so let's clear that up. just kind of bothers me to have these extra files there. Not a big deal. It's kind of, I'm sure any production Juniper you'll find these little files sitting around, but as somebody who is going for their expert level in Juniper, I kind of just think it's a little bit nicer to not have random stuff hanging around due to messing up on the CLI. Okay, so let's go ahead. Alright, so we've got the whole output. Yep, and we've got no next hop, unfortunately. Which is interesting because, oh, you know what? Well, this is mine. No next hop to what is what I don't understand. Oh, I see. So, okay, so we've got, oh, what is this? Now, is that right? I think that's right. The other side is going to be 1.10. Yeah, so it's 1.10. We're joining IGMP group. Let's do an equivalent of this show IGMP group command. See if there's one for Cisco. I'm sure there is. Okay, so we do have a okay, so the expired stop, so that looks good to me. Let's see membership. Oh, you know what? I have to specify the group. So let's do 239.1.1.1. Oh. Oh, here we go. Huh. Alright, I don't really know how to interpret that output, unfortunately. Oh, and that's interesting. I can't even... Oh, no, I can. Okay. I was worried if I had 172.16. Gah! Ugh! Yeah, using 172.26 is a bad thing. You can see I've got 172.16 on the loopback. That's why things aren't working. Alright, so let's see what we got on the other ones. I probably used 16 on those as well. Okay, this one looks good with 26. 26. 26. 26. 26, this is the same as the ones. Okay, yep, so they've all got 26. I just completely borf. Is that a good word for it? I borfed it. I don't know if that's a word that exists or not, but I think borf really kind of sums up pretty well what I did. I borfed it, so let's see if things look better now. Post-borf. Aha! So now we've got a upstream interface. It's local. Let's compare this output against what it was earlier. Okay, so let's see what the differences are now that I have fixed the problem with the family INET address on the loopback interface. The second octet was 16. It needed to be 26. Okay, so we've got a big difference here, which is the state. So it looks like beforehand, before I fixed it, we did have state up still, but we did not have a DR address. Or if we did, one of them started with .1. Okay, so let's look at the next one. Alright, okay, the differences are just the uptime, so really no differences at all. Okay, now we've got, oh, the timeout is different, so no differences for this one too. So here's the major difference. Before we had an unknown upstream interface, no next hop. That's because the RP was defined as 172.26, but the loopback was 172.16, so it did not have a known RP. It was unknown. But here we do have a local interface, the loopback 0.0 interface, because that address matches the address we gave for the RP. Here, there was a discrepancy. Okay, so anytime it was an unknown interface, it is now a local interface. Uptime, that sort of stuff was always going to be different. Yep, so last joined, yep. So I guess I'm just kind of surprised it has so many things that appear to be innocuous, with there being such a big error in the IP addressing. That's kind of problematic in a way for me. I mean, I guess it's pretty clear that your upstream interface is unknown. Really can't get much clearer than that, but definitely if I weren't putting the time in, and unfortunately I took some time off yesterday, this would definitely get me pretty bad. Okay, so we're going to clear all active compares. Next step, we're going to try to rerun the show commands, and hopefully it looks a little bit better. The other thing I'd like to do is do a Wireshark capture, and hopefully we'll see PIM messages spamming more than we saw them before. Before, I think I got one message, but when I looked at his video, his screen was filled up with messages. So still I'm really not getting any messages. Alright, so let's run those commands again on different routers. Okay, and I'll just keep that up. I mean, these are just show commands. They're not going to affect what comes up here, but I just want to keep an eye on it. And here we've got empty. But it's meant to be empty. I think router 3 is where, yeah. Oh, no, router 3, okay, well, I'm confused now. You know what, let's make it easy on ourselves, and we'll just do a, we'll just take a look at the active configuration for anything that says .16 instead of .26. Undoubtedly, I could have made further errors in that regard. It's really just kind of a matter of habit to put in 172.16. Okay, so if we've got any results here, we'll need to change it to .26. Alright, so let's check the rest of the routers. Alright, everything looks good to go. Yeah. It's good. Alright. Okay, so yeah, here's the part where he said it makes sense that we're not going to see anything.
Open join, nothing. Run show pim RP is extensive, and there's nothing. And that actually makes sense, because if this was a Unicast message, then R2 really did not have any need to process that message at all. So it's a Unicast message. It literally just tunnels its way through R2. R2 just routes that packet over to R3 without ever checking the contents of it. So it's doing that hardware switching. It switches it like any other packet. So it's not interested in the contents of it. So that means R2 is not really part of this S-G state, which actually makes sense. So as of this point, there is really no need to send traffic on that tree. R1 and R3 just need to be aware of that tree. So you have an S-G state here. You also have that S-G state here. But on the middle hop router, there is nothing here. And you expect to see nothing here. So that basically jives with what we have learned. Let's quickly take a look at that register message in our packet capture. So I'm going to say pip is 1 for register. Or
okay, so now this is a register message. So this is a result of what he did earlier. So let's see if we've got any results for register. I don't know why my browser is so bad. I'm kind of worried about using this computer. Okay, we've got some comments here that are getting in the way of my results. Oh, you know what? Maybe it's in the... yeah, maybe it's matching here, but not showing me the results. Oh, here we go. Now we're in the...
more for the use of this lecture. More often you are going to have receivers if a source is sending interesting traffic. So R1 should then create that PIM register message. It should be a Unicast message, and it should be headed to the RP. The RP should then update its own state with S-G, and it should send a register stop on account of there are no receivers right now present in the topology. Also, that PIM register message is a tunnel message. So in here, you should also see the multicast packet. So we want to ascertain all of those things. So number one, that register messages are indeed unicast, and then that they also help tunnel the multicast packets inside them. So let's go ahead and into our topology to see what is going to happen here. So here's R1, and just to make sure R1 has the proper ID of an RP, let's say show or run show bin RPs. So it has a good idea of the RP right now. And if I say extensive,
oh, we've got an RP address of .3 here on R1, but the RP address here is .1, so that's going to be a problem. Yeah, I think the static RP address has to be .3. Like, I think you just have one. Like, that's what a rendezvous point is. Like, you don't all rendezvous at different points. You all rendezvous at the same point. That's the point of a rendezvous. Like, let's look up the word rendezvous. Rendezvous. Okay, well that's how's it pronounced?
Rendezvous.
Oh, so it is Ron. I don't know why Ron is spelled R-E-N instead of R-O-N, but what it means is a meeting at an arranged time and place. So our arranged time and place is going to be .3. Okay, so I'm very, very rapidly running out of time here. But let's change all of these to .3. At the very least, these two here. Definitely have time for that. Yeah, so they've got to have, of course, all their own loopback addresses. But for the rendezvous point, it's literally a point. It's literally a rendezvous point. So it's a point in your network where they all gather, which is going to be .3. Okay, so let's see how things are different. So it looks like we got some IGMP messages. Let's use the commands. Okay, so these filled in now. They weren't filling in before. Let's go back to where we ran. Yeah, where we ran them last time. The commands weren't filling in, but now they're all filling in. So I think that's a good thing. These should not fill in. Oh, these are filling in now too. What the hell? Okay.
I can see that there is no other information here. We know that the configuration was put in statically, so no dynamic dissemination protocol will be used, and which group ranges are covered. So run show bin RPs. Yeah, I don't see anything else here, but that's mostly because there is nothing else to see here. Next thing, let's go to our source. And the source is going to just send, say, 5 packets. So let's send 5 packets out to that multicast group. So we'll say ping 239.3.3.3, and we'll say repeat 5. By default, for multicast, it only sends 1, so we'll say repeat 5. So here we go. There's 5 packets going out on that multicast address as we speak. So on R1, if I say run show bin join, I do see that group. So I do see that group, and let's say extensive here. So on R1, I'm actually seeing information about that particular group that is active in my topology. Now I might be mistaking my earlier assertion with the RP. So I think the RP may not show this information. But fortunately, you don't have to remember that extra tidbit for the FHR because it's pretty clear. The FHR has this information right here. So what is the group? 239.333. There is an explicit source for this group, so it's not a star comma G, because now you know the explicit source. It's 1.10. That's the address for my source. It is a sparse. So, like I said, the sparse flag is there on every single one of these, every single one of the PIN packets. That's for version 1 compatibility with version 2.
Okay, I think that's going to be it. Unfortunately, I couldn't get, well, you know, let's put it this way. I think I learned something. I learned more about the rendezvous point. I learned that definitely on router 1, you need it to point to .3. I did not know if you needed to be .3 or .1. I went with .1 and things didn't work. Things seem to be working better now. We've got output for this. Let's just quick try to ping .1.1.1. I'm not sure where .3 came from, but we'll try. Let's try .4.4.4 just because I'm curious if now that's gonna pop up here. Ah, it is. Okay. Well, that's interesting. And then just to be extra super sure, let's do .5.5.5. Yeah, so it looks like whenever I do a ping, I get an extra group showing up. But you can see the group is not actually a group that is configured. If I do a show pipe configuration, pipe display sets, pipe no more, on all of the routers, I believe there is a router with that group explicitly configured. Okay, so I'd be wrong about that, but I think one of the Cisco switches will actually have it. So let's check that quick. It should be an IGMP group. Yep, IGMP join group. So I don't know why we're trying to ping a group that we're not joined to, but let's ping one that we are joined to. We should hit those other hosts that we had. I think. Oh yes. So we're getting replies. Perfect. We even got one with 4 milliseconds. So. Yeah, it looks like we were able to do that. Just one final extra super thorough thing. I would like to stop this wire capture, and then I would like to sniff a link here, and then I would like to see if on that link we actually see responses. If we do, then I will be done. I don't have a group meeting today at 1, so I can go a minute or two over. So let's try that. So I was expecting ICMP to go, yeah, I was expecting the replies to be sent over the network. Let's try it. I was kind of hoping there'd be like a bottleneck or something. Let's try this link. And I'm gonna have to end that video real soon. I think we've got time to try this one link. But whether we see it or not, we're going to have to end the video. So let's look for ICMP traffic. I'd love to look at some more links to see if there's ICMP traffic being sent to a multicast address, but fortunately I got to end it there. So thanks for watching, and I'll see you in the next one.